Do you know how the heart pumps blood? How many heart sounds can be heard? With what significance? With all these questions, let's learn about the pumping process of the heart. The heart contracts and relaxes alternately to promote blood circulation. Atrial or ventricle contract, relax once, form a mechanical cycle called cardiac cycle. It's in inverse proportion to heart rate. If heart rate is 75 beats per minute, cardiac cycle is 0.8 seconds. How is the time allocated in the cardiac cycle? The period in which the heart contracts is called systole, while the heart relaxes is called diastole. Because of the alternation of systole and diastole, we use a ring to represent cardiac cycle. The inner ring represents atrial cycle. Outer ring represents ventricular cycle. The cycle is divided into 8 parts. Each part represents 0.1 second. We can see that in each cardiac cycle, atrial contracts for 0.1 second, relax for 0.7 second, ventricle contracts for 0.3 second, relax for 0.5 seconds. In each cardiac cycle, no matter atrial or ventricles, diastole is longer than systole, being conducive to the nutrition of the heart and the filling of ventricles. From the figure, we can see that the atrium and the ventricle do not contract at the same time. Ventricles begin to contract just at the beginning of atrial relaxation. What's the reason? Yes, you are right. It's due to the AV delay. If the heart beats faster, the cardiac cycle would be shortened. Due to the large fraction of diastole, the shortening of diastole is more evident. Since the activity of both ventricles are almost the same, we take the left ventricle as an example to introduce the pumping function of the heart. When the pressure in ventricle is greater than that in atrium, AV valve is pushed to close, so blood would not flow back into atrium. At this time, the pressure in ventricle is still lower than that in aorta, so the arterial valve is also closed. The ventricular volume did not change for a long time, known as isovolumic systole, which lasts about 0.05 seconds. The pressure continues rising with ventricle contracting. When it's higher than that in aorta, arterial valve open. A large amount of blood is ejected into aorta rapidly, which is called the rapid ejection period. Lasts about 0.1 second. The blood volume ejected during this period accounts for 1/3. In the last stage of ejection, with the increasing of arterial pressure, the ejection slows down. It's the reduced ejection period, in which 1/3 of the ejection volume is ejected into aorta. It should be noted that the reduced ejection period, the pressure in ventricle has been lower than that in aorta, but because of the high kinetic energy, the blood continues into the aorta. After systole, ventricle began to relax, and the pressure decreases. When it is lower than arterial pressure, the blood in aorta flows back, pushing arterial valve to close. At this time, the pressure in ventricle is still higher than that in atrium, so the AV valve is still closed. Therefore, the ventricle becomes a closed cavity called isovolumic diastole. Ventricle continued relaxing, and the pressure continued dropping. When it is lower than that in atrium, AV valve opens, and a large amount of blood rapidly enters ventricle, which is called rapid filling period, lasts about 0.11 second. 2/3 of ventricular filling enters at this period. With the filling, the pressure in ventricle rises, and the suction force decreases. The filling slows down and enters the reduced filling period, which lasts about 0.22 seconds. In the last 0.1 second, the atrium contracts, increasing the ventricular filling by 10 to 30%. Then, ventricles begin to contract again, enters isovolumic systole. In the heart pumping process, we can see that the contraction and relaxation of ventricle is the main reason for the change of pressure, and the pressure gradient is the main reason of blood flowing. Due to the valves, blood only flows from atrium to ventricle, then to artery. Ventricular filling mainly depends on the suction produced by ventricular relaxation. Clinically, if the synchronous contraction of atrium was destroyed, atrial fibrillation would appear, and the atrium lost ejection function. Although the ventricular filling is reduced, it can still meet the metabolic needs of the body adequate. If ventricular fibrillation appeared, ventricular ejection stopped, as can threaten the patient's life. So, the ventricle plays an important role in the heart's pumping function. In the cardiac cycle, the mechanical vibration can be heard, called heart sound. Two sounds can be heard by oscillation. The first sound is low and long. It is mainly produced by ventricular contraction and the closure of AV valve. It marks the beginning of ventricular systole. It can be heard the most clearly at the heart apex. It can reflect ventricular contractility and the state of AV valve. The second heart sound is high and short. It's mainly produced by the closure of arterial valve. It indicates that the ventricle began to relax. It can be heard clearly at arterial valve area. It reflects the level of arterial pressure and the state of arterial valve. summarize what we have learned. Ventricle contract, relax alternately to complete the pumping function. In cardiac cycle, ventricular systole accounts for 1/8, including isovolumic systole, rapid ejection period, and reduced ejection period. 2/3 blood is ejected in the rapid ejection period. Ventricular diastole accounts for 5/8, including isovolumic diastole, rapid filling period, reduced filling period, and atrial systole. Ventricular filling takes place mainly in the rapid filling period. In the pumping process, heart sound can be heard. Two sounds are often heard by oscillation. The reason, significance, and the clearest oscillation place need to be mastered. That's all for this class. Thank you. See you.